Hello.
Don't you hate it being recorded?
Not
I hate
really.
being the annoying jerk sticking cameras in
I'm
people's
Robert
faces.
Tagg. Welcome to the meeting.
Thanks, Robert. Now we have a huge spread here. Brantley is digging in.
Yes, we're going to taunt everyone with the food they could have if only they
Vegetarian food. Plus.
And vegetarian food. Which, not having any vegetarian food at a ChiPy meeting would be like suicide.
Oh, we should have some vegetarian food.
We do.
No, you're doing great.
Look at that. Very nice. This is 20 minutes before the meeting.
What we're going to do is that we're going to create a variable called a list, and it's just going to be a list containing the number 1. And then we're going to make an object that's a tuple, which is similar to the list, only it's immutable, meaning that we can't like add stuff to it. And we're going to have it be a tuple containing that variable and then another instance of that variable. And then what we want to do is that we're going to just import pickle, which is just as easily as saying import pickle. And we're going to say pickle.dumps, which means dump it to a string. Essentially convert it to a binary form that's a string. And we get this gobbledygook. It's basically just like secret code for constructing this. And the really interesting thing about this is that if you're new to Python, this is kind of a funky situation here because we have this object that is sort of like an immutable list. It's a tuple. And it's referring to this variable twice. So the funky thing here is that if we were to print this out, we'd get this basically. But if we were to take a list and say append the number 2 to it, then this would actually appear as 1, 2 here, and then this would also say 1, 2, because it's actually pointing at the same object. And the neat thing about pickle is that it restores those relationships. So the actual object that you're getting when you load the secret code is that these two objects are actually pointing to the same object in memory. If that makes sense. Isn't that, feel free to raise your hand right now. I don't understand anything here. And so one neat thing, going to that sort of like computer game example, is that this works with class instances too. So we can say that we make a class called a player, and for now we'll just say that there's one attribute to it called name. And when you create it, this is basically object-oriented Python speak for your constructor. When you create a player, we'll print out players created, and then we'll just assign the name that's passed in to the object. And so then we'll just create an object of the player here. And you'll see that it's calling this because it says it prints out player argon created. And then we're basically doing the exact same thing that we did before. We're just saying pickle.dumps. And here, this is the gobbledygook it's spitting out. And it actually prints out more than that. I just filled it with an ellipsis there because it wasn't worth putting all the junk on this side. And you'll see that it's actually not all entirely gobbledygook. Like there's sort of, there's like English text that you could read in here, which is interesting. And we'll get to that later. And essentially, in Python, this is actually sort of like a copy of an interpreter session. When you just type Python, you're in the interactive interpreter. One neat thing about it is that this variable underscore just means take the last thing that I evaluated. So take this string. So it's just shorthand for saying load up that thing that I just pickled. And just as sort of a proof of concept, we're saying, okay, clone player, what's your name? And it says Argon. Now, the really interesting thing here is that when it sort of like recreated the player, it didn't call the constructor because it didn't print out player Argon created. That sort of weirded me out when I first used this. It was like, what the heck is it actually doing under the covers there? So some other things about this. Pickle isn't technically secure. There's one file called pickletools.py says that no sufficient security analysis has been done to guarantee this. There isn't the use case that warrants the expense of such an analysis. So there used to actually be some security stuff defined about pickle prior to like Python 2.3 basically, and essentially in 2.3 they just like threw away all of that, all of this sort of like what do you say? this facade that this thing was actually designed with security in mind. And they were just like, you know what? Screw it. We're just going to say that this is entirely insecure and only get pickles from sources that you trust. And another neat thing is that pickle is cross-platform. The actual format, like the binary format that it's saving it in, there's actually 3 different versions, version 0, 1, and 2. Version 0, which is what you saw before with that gobbledygook, that's actually text only. So it was actually sort of made to be semi-human readable. And then versions 1 and 2 are platform independent also, and they're binary.
Is version 0 platform independent?
It is because it's text, essentially. And I think that with new lines, I'm not sure if it technically deals with new lines properly, but it essentially is, because it's basically just text. Yeah, and it's interesting because they're actually just, version 1 is actually a total superset of version 0, and version 2 is a total superset of version 1. So if you have an unpickler, as it's called, that's written for version 2, it'll take a version 0 pickle. So if something was pickled with Python 1.5, back in 1995 or whatever, you can still load it up in Python 2.5 today. So, as I sort of hinted at earlier, there's some unanswered questions about this whole process. For instance, why isn't the player constructor called? That's kind of what we're saying. Yeah?
Well, we understand is you create an object and you assign a value to the property of the object. Then when it unpickled it already had the value. Why would we have to redefine the object? That's the part I don't understand.
Could you repeat that last part?
You defined an object and you gave it a name, and the property was populated with a name. And you pickled it. If you unpickled it, why would you have to go through and redefine the object? It already has the value. That's what I don't understand. Player's an object.
I think you got the same confusion he had.
Yeah, you might have.
Why would you want to have to redefine it again? It already has a definition.
Oh, I'm not actually defining. You mean here?
It's in 2 separate sessions. So the idea is you could have shut that session down, saved the pickle to a file,
Yeah.
and loaded the pickle from a file.
Yeah, and an interesting thing to note here is actually, you'll note that I called this this variable cloned player. It's actually made a complete copy of this player object. So clone player is actually a completely different thing stored in memory from player. If I was to change clone player's name, it wouldn't be reflected in this player's name. And so it's kind of interesting because a lot of the semantics of pickle and a lot of the funky stuff that goes on in its process of essentially restoring, of unpickling this, is actually very similar semantically to what the copy module does. There's another module for Python called copy that makes copies of objects. And semantically, they both work very similarly, essentially. Did that answer all your question?
I think the problem is that Atul here is assuming that when you recreate the object, it should somehow call that constructor, and you're not. So that function, he's thinking that when you load the pickle, it should recreate that function.
I don't think so. I think it's already
Exactly.
all the information it needs.
Okay, yeah, and
You don't
that's
see
actually
that.
exactly it. You're exactly right, and my intuition was basically exactly wrong.
There's
So-
one situation where people might be expecting that sort of thing, that sort of behavior for the constructor to be called again, is if you're doing some sort of external bookkeeping in the constructor.
Exactly, yeah.
Which, and if you're assuming that every time you create an object of that type shows up, that constructor will get called,
Yeah.
then you're going to get shot in the foot if you use pickle, because pickle will make other copies but won't actually call that constructor.
Exactly, yeah. And so that was what I was sort of worried about, is that, yeah, what if I do funky things in my init, and then when I restore it, it's not really restoring my state because it's not going through that stuff again. But what you said is basically exactly right. So then there's that. So yeah, questions, that. What if I were to add a new attribute to the player class? What if in that constructor, I also had it take a parameter that was like, you know, the player's strength attribute or something like that. Or what if I change an instance method, you know, like added another method that that printed out the name in a special way or something like that? Is the pickling actually saving the code for the actual instance methods, for instance? What if I move the player class to a different file? How is that pickled thing, when it's unpickling it, how is it going to know that, oh, you know, is it going to just raise an error and say, oh shoot, I'm expecting there to be this player class in this one file, but there isn't a player class in this one file, and now I'm just going to die. Like, but, you know, when I'm refactoring, I might really need to move that player class to a different file, and that's going to suck if all of a sudden everyone's saved games are just invalid because of that. What if there's things in a player instance that I don't want serialized? Like, what if I'm making a network game, and the player instance actually has a socket object associated with it that points to a network connection? I don't want that socket object serialized. So this sort of gets to the question of what a pickle actually is. And it says in pickltools.py, which is basically a really great source of documentation, that a pickle is a program, actually, for a virtual pickle machine, or PM. It's a sequence of opcodes interpreted by the pickle machine, building an arbitrarily complex Python object. So this is actually a pretty simple machine, which is neat. Basically, there's two data areas in this machine. There's a stack, which is just sort of like you can envision as a big stack of stuff. Like, it starts out with nothing, and you can say, push this thing onto the stack, push this other thing onto the stack, pop it off of the stack, and the thing that's on top of the stack goes off. And then there's this thing called a memo, which you can basically think of as a dictionary that essentially maps integers that are sort of like object IDs to actual objects. It's really simple. It doesn't have, this machine doesn't have any looping instructions, testing instructions, conditional jump type instructions. Doesn't have any arithmetic instructions. You can't add things or anything like that. It doesn't have any function calls. It doesn't have any method of like defining functions or anything like that. Any syntax for it. And the operation codes are executed from first to last until a stop instruction is reached. And basically, once that stop instruction is reached, it just takes whatever's on the top of this stack, and it says, okay, that's your pickle, that's your restored object. So, this is sort of where things get funky. Basically, what we're going to try to do is that that pickle tools.py thing, I mean, it comes with Python. You can actually just import it, and you can call a function in it called dis. And this is actually, is that it's showing you a disassembly, and these are literally the opcodes of every single part of this program. I mean, this is literally a program that's being executed. And so essentially, hopefully we can just go through this quick. I was hoping I would have a whiteboard here where I could draw stuff, but hopefully this thing's simple enough that people can sort of keep this in their head. Essentially, what this mark instruction means, which is literally just the character, I mean, the operation code is literally just this first parenthesis. That basically means that's like code for mark. And what that means is that you put something called a mark object on the stack. And all that, we'll get to that later. It's just later instructions will essentially use it. And then the next instruction is to basically put another mark object on the stack. The next instruction, which is L, is to build a list, is the list instruction. And essentially what the list instruction means is go to my last mark, take it off the stack, and then build a list with everything from that last mark up to my list instruction. So in this case, there isn't really anything between mark and list on the stack, so it's going to make an empty list. And then step 3, put, and then this argument 0, that's what this P0 is. Put 0 basically means take what's on the stack, which is this empty list, and put it into the memo, which is that other data area. That's like the dictionary that maps integers, which in this case will be the number 0, to objects. So in this case, it's going to say, okay, the number object ID 0 is going to point to this empty list. Then what we're going to do is that but put does not pop that list off the stack. So that empty list is still on our stack. And that's essentially, there's that list, and below it is this mark, this original mark that we put on there. And then what we're going to do is we're going to put the number 1 onto the stack. So now we've got the number 1, an empty list, and a mark. And then we're going to execute the append instruction, which basically means take the last 2 things on the stack. The first immediate thing on the stack should be a thing that I want to add to a list, and the second thing under it on the stack should be the list that I want to append it to. So basically just add the number 1 to that empty list that we've got. And you might be thinking, why didn't we actually just put the int1 instruction here instead of like creating this empty list and then appending to it? I think that would have been, I think that is just in idiosyncrasy of the way that, that the thing that made this code generated it. I think it's just kind of inefficient, which is part of why they actually made these future protocol versions later on. This is actually protocol 0, so this is the simplest protocol, but it's also the most verbose and sort of inefficient one. So basically at this point, we've got a list with the number 1 in it on the stack, and right below it is that mark object still. Now get 0 means go to our memo and find the object with ID 0 and pull it out of there and put it on the stack. Actually, we don't mean pull it out of there because the memo is still going to contain that, like a reference, an entry for object ID 0. But it's going to put another reference to it on the stack. And then we're going to execute. So now we've got, I believe that we literally have 2 copies of the exact same object on the stack. And under those 2 copies is a mark. And then we're going to execute the tuple instruction, which says go back to the first mark we can find and take that and all the objects in between it on the stack and make a tuple out of it. So essentially, we're just going to make a tuple out of those 2 identical objects that we have on the stack. And then here we're just going to assign object ID number 1 to that tuple, which we don't really need to do because we're about to stop. And so then essentially we've just got one thing on the stack, which is this tuple containing 2 identical objects, which is the thing that we pickled in the first place. And then this thing just means that, we can just actually sort of ignore that, but that just means that when it was disassembling it, of all the opcodes that it found, none of them were in the more advanced protocols that were invented at later times, because when you pickle something, it actually just uses the earliest protocol by default, protocol 0. But that's essentially it. Unfortunately, I didn't have a whiteboard or anything, and at the time I was sort of too lazy to make a cool graphical thing or anything like that.
But it's a Mac, it's so easy.
But I hope you got just the general gist of it. I mean, there's these two areas, the stack and the memo, and you're just constantly pushing stuff on the stack, putting stuff in the memo, and building stuff out of the stuff in the memo. And that allows you to do neat stuff where you can have objects that have circular references to them and all kinds of weird stuff. And so that's really just the general way that all of the pickling stuff works. It's actually like a little program. I thought was kind of neat. Now, just for fun, so essentially, I actually wanted to actually disassemble a pickled object instance because I really wanted to know what was sort of going on underneath, under the hood when I would pickle the player class. So here we're essentially just taking that thing where the ellipsis is a whole bunch of other gobbledygook. And essentially there's just all of this junk. You'll notice that there's a command here called global, and it's actually got sort of 2 parameters. There's a intentional space right here. So it's sort of copy reg and underscore read constructor, main, player. That looks familiar, obviously. Main is sort of the name that it gives a Python module that is your script when you're executing a Python script. And built-in object is just the object class that the player is a descendant of. But essentially what all of this junk is doing here, and you'll also notice that there's this funky reduce command. Essentially what all of that stuff is doing is it's literally an equivalent for this. Copyreg.reconstructor, and then the arguments are main.player, built-in.object, none, and it's actually going to return a player object. The question is, what the heck does this copyright reconstructor do? So cool. Okay, and so basically, I have no idea exactly how this else gets executed, so sort of ignore that. But basically, base is object, which means that the base of our player class, the base class of it, not the superclass, but the actual base class from which it ultimately derives from, is the standard object class, the root object class. And then class is the actual class instance that we're making, and state we're just passing in as none, so ignore that. And so essentially what it's saying is that base is object, which it is. Object equals object.new, and so there's this funky new method that's getting called. And then it's basically just returning that object. And so basically what I sort of found out about this was that new is essentially, it's sort of the, I don't think that, I might not understand it completely well enough to be able to describe it very well. But essentially what it is that it allocates memory for the object, and for instance, you'll note that in that constructor, when we have that underscore init underscore self, comma, whatever, we already have that self. Like, that self is already created. Which means sort of that an instance of our object, to some extent, has already been created. It's just sort of waiting for us to actually assign attributes to it. The new class method, which is defined in object, and generally you never really have to actually override this thing unless you're making some funky like extension type. It's the thing that actually allocates memory and sort of creates that self that gets passed to init. And so you could sort of think of it as like a naked object that has been created, and all of its sort of default behaviors are created even, and because you passed it an instance of this class, it even has an idea of what its methods are and stuff like that, but beyond that, the instance itself doesn't have any real data.
So I was going to say, I think that else is for objects that are based on lists or dict or something like that.
I think it's meta classes.
Yeah, I think you might be right.
I think object is the meta class of player.
Yeah, it's funky, and I can't get into too much detail about it because A, it's out of the scope, and B, I don't really know. But basically, essentially what it's doing is it's sort of creating a naked object. And one of the things that's really neat about Python that's neat about Python objects is that an instance of a Python object has this attribute called __dict__. And one of the really cool things that you learn about your own custom objects when you're creating them is that your object's instance attributes, so like the name of the player, for instance, are actually just string keys in that dict. And so you can actually like dynamically add instance attributes to your object instance, by just saying like your object dot __dict __ update, which just basically takes what the current dictionary is and updates it with these new values of this dictionary that you pass in. And so it's just this sort of really neat kind of how do you say it, like conflation of the concept of a dictionary and an object instance that I thought was neat. But it's something that you sort of, essentially what we're creating here is an instance of the class whose __dict__ is completely empty. So it doesn't have like that name attribute that we assigned the Argon player, for instance. So hopefully that makes some sense. But what that means is that we've got this sort of like naked object, which is just like weird. So essentially, this is sort of continuing on from the rest of that program after it made that naked object. Essentially what it's doing is that it's marking a thing, and essentially it's starting to create a dictionary, and it's clearly setting the name key to Argon, and then it's calling this build thing. And essentially what build does is that. Like that whole code was essentially just shorthand for that. And so that's basically essentially what's going on. It's complicated a bit by the fact that actually in Python's history, I think it was like Python 2.2 or 2.1 or something, that they actually introduced, you'll notice that that player class was descended from object. You didn't actually have to do that. You could have just said class player colon, but it would have actually been an entirely different kind of object called a classic class, or it would have been an entirely different class called a classic class that internally works very differently from the player class that was descended from object. And unfortunately, all of that makes understanding how Python works internally a little bit harder. One really neat thing is that with Python 3.0, which is going to hopefully sort of replace Python, the 2.x line, one of the things about Python 3.0 is that they're basically saying, you know, to hell with backwards compatibility, we're really sort of refactoring this language and making it a lot easier to understand and use. So one of the things they're doing is just killing that whole classic style classes thing. And an advantage of that is that it's going to make understanding things like how these things work internally a lot easier. But basically, now that you know sort of like the full pipeline of what's generally going on when you're pickling something, it's a lot easier to understand the actual documentation, which I'm not going to go into. Essentially, you can, when you create a class, you can actually, with that player class, for instance, we could have defined two custom methods called getState and setState. And essentially, that part where we created that dictionary in the pickling code, and it automatically assigned that dictionary to the object's dict and set its name. Well, this part. Essentially, getState and setState let you override this. They let you sort of hook into it in a different way and basically say, no, instead of just getting my underscore underscore dict and then setting my underscore underscore dict when you unserialize me, I want you to call my getState, and I'm going to pass you back some sort of object that you're going to essentially pickle, and then when you're unpickling me, you're going to call the setState thing, and I'm going to manually look at that thing and set and use it as a thing to set my own instance attributes. GetNewArgs is sort of another way to do that, except it sort of goes through the constructor. It's a way to allow the constructor to get called in that way that I found really unintuitive earlier. You can also subclass picklers and unpicklers. In particular, one neat thing you can do is override an unpickler's findClass method. FindClass is used back here. The way that it gets main player built-in object and copy reg reconstructor is that it's finding these things. Essentially, whenever it runs into a global instruction, it's actually calling a particular method on an unpickler class called findClass. And so, for instance, that would be a way that if you've actually moved the location of your player class, you could create a custom unpickler that basically has a findClass method that's essentially similar to the default one, only if main.player was moved to, like, you know, playerClass.player or something, or playerModule.player, it would be able to say, oh, okay, you want me to get a thing in the module main with the class player. I know that that's been moved, so I'm actually going to get playerClass.player and return you that object. It's essentially a way of, it's also a way of making the pickle protocol slightly more secure. But essentially, that's just sort of like a whirlwind tour of that.
So while you're doing that, you don't it doesn't actually save the class definition?
No, it does not. And that's one of the interesting things, is that if we saved player, we would essentially, and we didn't do any of the special customization, it would essentially, like, it sort of gets tied in with exactly what it means to have an instance of a class. When you have an instance of a class, the methods of that class, like the code of it, sort of, is they're not actually properties of the instance. They're properties of the class. So when you say, like, if we had a method on the player called, like, getName that just returned player.name, player.getName, getName, that sort of key, is not a member of your player's underscore underscore dict underscore underscore. It's actually the case that when you say player.getName, what it does is it first looks in that dict, and it's going to look at that dict and it's going to say there's nothing called underscore underscore getName here. And then what it's going to do is that it's going to be like, okay, what's this object's class? And then it's going to be like, okay, this object's class is player with a capital P. And then it's going to look at that and say, does that class object have an attribute called getName? Yes, it does, because it's a method of that class. And then it's going to call that thing. So that in that sense, it sort of makes sense that it's not saving that, because what you're really pickling is the player instance, not the player class. Although I think that it actually technically is possible to pickle a class. You just probably wouldn't want to do it very often. It would be kind of scary. Oh, you can't do it?
No, code
Oh, okay.
objects can't be pickled.
Okay, code objects cannot be pickled. So where to go next? There's actually a module called CPickle that doesn't let you customize stuff in all the myriad ways that you can with Pickle, but it's up to 1,000 times faster than Pickle. So if you're using it, you're probably going to want to use CPickle instead. For more information on the Pickle machine internal, see the source code for this pickletools.py thing. It's actually incredibly well documented. And like every single opcode in there has its own documentation that you just do a sort of search for this opcode name when you run into an opcode you don't know, and it explains it really, really nicely. And then one thing I didn't mention on here is that if you're interested in just learning more about all those class internals, like how is a class actually built, and things like that, the best source I've actually found for that is Dave Beasley's Python Essential Reference. I actually haven't really found a place online that gives quite as sort of succinct and clear explanations of how all that stuff works as his book. But that's pretty much it. Yep.
So if pickle is really just saving the dictionary of
You need to move. No, don't worry about
I'm
it.
just gonna get off now. And it's pretty easy. You open up main.py and you give it the specific XML file that you want to run. And in this case, ours is stage.chippy stage.xml. So let's leave it on. And by the way, this is on a really crappy T23, so when I run on this on my computer, all the animations are nice and fast, and then when I run it on here, they're like choppy, and I kind of feel bad about the way I programmed it, and everything's really inefficient, but too bad.
You got the girl.
So greetings, Chippy. Welcome to PyStage Talk. That guy's holding an arrow, by the way, in case you thought it was something else. So we've got this thing called PyStage. This is PyStage. It's an animation framework to make stupid animations. That guy shot a fireball. So what is PyStage and why is PyStage? And here I'm going to embarrass my fiance who's here. And basically I was proposing to Morgan. Actually, I didn't just want to propose at the Barrett Chapel. We wanted to get married at the Barrett Chapel. And we couldn't because DePaul bought Barra and then closed Barra. And so that kind of made things difficult. And also, Morgan kind of gave me a suggestion. I warned you guys I'm going to embarrass you. That she said, well, I know if you're going to propose that you're at least going to be really creative about it. And I really took that to the extreme. So
slightly misquoted.
Okay, yeah. I'm good at misquoting. So originally I was gonna make a game for some godforsaken reason with cutscene animation. Now why proposing with a game was a good idea, I have no idea. But then I discovered how difficult it was to build the cutscene itself. And then I was trying to build a cutscene and I was just, I was doing it the way you'd think, oh man, just make this animation, it's really easy, I'll just hack it together and I'm just hacking away and I'm like, oh god, just like hacking all this stuff in code is really awful. And I was going crazy and I was like, well, what's the way that I can end up feasibly making this? And I thought, well, I have some very creative younger siblings, and I was thinking, how would my 10-year-old brother and my 11-year-old sister and my 17-year-old brother, how can I make a system that was easy enough that they could start messing around with? And easy enough that I could be not stupid enough to actually work with it. So within those constraints, I started to make this system. And there's some core concept. There's an engine, which basically just controls everything, of course. You can implement some generic images and sounds, though I never have done it so far. You can have multiple scenes, though throughout this entire presentation we're just using one scene. But you can switch back and forth between them, and things will resume from the way that they were in the other scene. And you have actors, and this is the core of it, and they come from these actor templates. And all this is in an XML script, which looks pretty much like this. This is from my test animation that I worked on when I was afraid that she might walk into the room and I didn't want, to give away what the heck I was doing. It's pretty simple. You start setting up the actors here and so on. Actually, I'm going to describe that later, so I'm not going to. Just take a brief look and we'll move on. So, how the XML is laid out. Okay, now we can go back. You define your generic images and sounds, and then you define your scenes, and then you define your actor templates, and then bam, you can get into the script and how it all works together. And so if we take a look at this, here I first start to define this actor template, and this is the beholder. Think of eye of the beholder. For some reason I've got
Make the
questions.
font bigger?
What?
Font bigger?
Maybe.
Options down at the bottom of the options menu. Set font, font set, a little up.
Oh, okay. Yes. Do you have a recommended font?
It's just something. Courier.
Courier 18. Okay, Courier is a popular one these days. You guys are ridiculous. All right. Well, anyway.
Thank you.
So anyway, you start out defining the actor template. You can give it some special attributes. And then you can define animations. And the animations are really easy to define. You start with, here's the animation blink. It's this big hovering eye. And it's, you can see, I load the graphics image for the closing is frame 1. It lasts for 100 milliseconds. Frame 2 lasts for 100 milliseconds. Frame 3 lasts for 100 milliseconds. It'll just keep looping through these by default, though there is a way that you can run an animation and then stop and immediately move on to something else if you only want it to run one time. But by default, they just keep looping. And so, most actors are animated actors. And now we have kind of this guy's little dumb brother over here. Animated actors can have a number of animations like waving. Wave to ChiPy, hi, how you doing? We could also make our guy dance maybe. I'm really bad at dancing myself, and I'm probably worse at drawing it, but pretty awful. So they're pretty simple. Well, I guess we already did look at the XML, but let's look at it again. So simple. Unbelievably, an idiot can do this. I can do this. We can also define our sounds here, and the scenes are pretty simple. You just give it a name, and who cares about those? And inserting actors is pretty simple, but I'm jumping way ahead of myself. That's at the script level. Actors only have a few core properties, and I think I actually mislabeled that. I think it was X pose and Y pose, but I called them per Y, X and per Y. Nobody cares. You say your image, and it's just a simple Pygame surface. And the thing is that your actor is actually a Python class, and it's defined by this XML. But actually, if you take a look, we can actually. You see I'm loading class actor, and that's literally a Python class called actor. And you can see how awful this is and how I'm creating the most advanced virus distribution system since Microsoft Office introduced Visual Basic macros. If you've got this, so here we have a completely separate class. For this actor, we've got a text box, and actually we don't need this, but whatever. But that text box is basically this thing right here. This is an actor. And I just keep jumping ahead of myself. But anyway, actors are rendered from the actor template, so we can insert multiple copies of them. So we can have multiple ones of this guy all dancing and waving, but that's kind of obnoxious, so let's get rid of it. So the monster at the bottom is an actor. Little guy who holds the arrow is an actor. And this text box is an actor. They're all actors, but of completely different Python classes. This one is a text box. And you can actually set the text oh God, This is my, this is, go to linuxparty.ytmnd.com and you'll find out why I put this here. But anyway, so my test animation, I just thought I'd put in, my girl likes to party, party. And you know, so like you can set the text and look, it's just a method of this actor. And then you give it the text. It's so simple, it's so easy. But let's move forward. So they can act out different methods, and those actions are literally Python methods. They're literally the methods of that class. You can see why this is really awful, but it's really extensible at the same time. And so the actions, like you saw when the guy walked across the stage, right? So we're using the ** keyword args to literally take the attributes of that XML, the XML element, and literally push them in as arguments to that action. And in this example, we're going for him to move right, we're going to do method equals move right and actor equals Draco. And you always need for an act what the method is and what the actor is. And then we're passing in actual keyword arguments to this method, including the distance, how many pixels he should move, and the speed at which he'll move. And so it actually turned into a dictionary like this. Now, it's not actually going to pay attention to method and actor, but it passes those in anyway. But distance and speed are actual arguments for that method. So we see he's walking across there, and action method then will also return a dictionary. And the dictionary that returns will actually be what it should be called with next time. So, if he ends up moving to the right, and he's moved forward 20 pixels, it'll return, if he was at 500 pixels left to move, it'll return 480 pixels. That way, it immediately knows, the engine knows to pass to it next time that it should only have 480 pixels left. So it's pretty simple to build. It's almost kind of like a mediated recursion, but if it passes back an empty dictionary, it moves on to the next action within the queue. So since actors know about their engine, and since they're Python methods, we could actually connect back to the engine and have one actor talk to the other. So you could have like this RoboCop actor sitting there, and there's a bad guy saying bow, 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 pow. Or I've never actually watched RoboCop, so I don't know what RoboCop does. But anyway, like it could spawn, and then that guy could spawn a bullet actor, which went off and went in the direction of one of the guys who's fleeing around the stage and actually hit him, and then send a destruction signal to kill him. So you can do crazy stuff by this really awful hackery of Python that I've created. And so if we're able to connect to each other and have the actors connect to each other, why not have one actor mediate the actual actions of another actor so we can debug and watch its output, what it's passing back? Well, that's exactly what I've done. And for this ChiPy, maybe it's a bad idea to spoil everything. But anyway, it's gonna basically handle. You can watch as it passes back everything that it's gonna be doing every time. Now let's watch it again, except slower and without the guy being animated, so that you're not all distracted. But watch. Slowly lowering the distance. These things don't change, but that's what it's being called with every time. It's really simple. And the way that this thing's able to set its images and everything is that it constructs. They don't have to be animated actors. They can put whatever they want with their image. So this thing is actually constructing, it's actually taking the font libraries of Pygame and actually blitting on top of it text. So you don't need to be stuck with PNGs or JPEGs or whatever. You can do whatever the heck you want to with this. So besides actor, there's a couple other commands the script can contain, and one of them's insert actor, and that's how you get them in there in the first place. You can wait, in which case all the animations continue, and there's also an update method on the classes, and all the update method will also continue to change on the class. And you can also kill the actor with any actor with kill actor. You can change the scene, and you can also play sounds. But when I proposed, I didn't use the play sound functionality because when I tried to play music with Pygame, it sounded like. And I was like, not a good idea. So I kind of removed that temporarily until I could figure out a better way to do this. So summary, it's a really simple animation idea, but I was able to do quite a bit. I actually threw together this presentation today. Took the day off, started at probably around 9 and finished it today. This whole presentation was done in PyStage, and it's not that hard to work with. In fact, the size of the presentation was, I think, rather small. Yeah, 284 lines for this whole presentation. It's not that hard to write. And I should stop spoiling things. But anyway, the next thing is just, so there's some, oh man, I shouldn't have jumped ahead. Well, I'll give my thanks and then I'll say the last point. So thanks, Tomas, one of my coworkers, I went with them and I gave him my original design. And he told me that it wasn't crazy, so I went forward with it. And Jeff here, we actually did quite a bit of game development together. So, that little guy that you saw running across the scene was something we created in a game that we were hacking together. And Morgan for telling me that if I ever proposed, I better well damn be creative about it, and for being pretty awesome and patient. So to skip back, to move backwards in time, I had one more point. And that other point was that I think that there's, in some of our conversations, actually Tomas said, well, why not do this with JavaScript? And actually one of the reasons why I've been really interested in animation is because, while I am interested in animation, I think it would be nice to have some forms of animation that were, easy to use for the average idiot like me, but not be Flash. And because Flash is really one of the, if you want something that's really, Flash helped out quite a bit. It's pushed things along quite nicely. I would like to see it die. There are quite a number of reasons, and I guess I won't get into such a big philosophical argument here, but it would be interesting to see. Could we do something like this with JavaScript? Well, for most, JavaScript has scalable vector graphics. I mean, the web has scalable vector graphics now on everything except for Internet Explorer, I think. Yeah. It would be really interesting to see what kind of things we could do to actually bring animations to the web that aren't Flash. But I don't know if this system is anywhere relative to what could work there, but it would be good to explore what the heck could be done. So that's pretty much it. There was a request on the list that I actually show, to further cause embarrassment here, that I actually show the proposal thing here. Should I do it?
Yeah.
Yes. And yeah, this is why I got the bash script here that kicks it off in XMMS because of the sound not working. So. I'm a lot cuter in animated form. So this is a Barrett Chapel, my drawn version of it.
Is that little bed?
what's the sum of it? I don't have the source code up anywhere quite yet, but I'm trying to redesign my website, and hopefully next week when I've got everything the way that I like.
The reason why I say the light, I have to pause. Okay, so
Managing.
I upgraded my version of Ubuntu last month, and it started doing this on projectors. I learned my lesson for upgrading. Anyways, I'm just gonna just do a real quick introduction of using Python and OpenOffice, which is for me pretty exciting. If you haven't used OpenOffice lately or ever, it's basically like functional parity wise, it's basically like Office 97. Which is pretty good for me because I haven't used any new functionality that's been in post that. And it's open source and free, and it has Python scripting now. So it's pretty exciting. So basically, like any other sort of big, massive, sprawling application, it has its own COM system. So so it has like an object broker that they call UNO, UNO, which stands, I can't remember what it stands for. But so it has its own huge COM system, and it started out as just being like a C++ thing, and then when Sun kind of took over the reins, they added some Java support to it. So now that they have like a lot of the architectural stuff in C++ and Java, they can start adding all these support for other languages via either methods. So like the Python support is actually CPython, some random version that they shoved in a directory and install. And there's also support for like just like straight up Java and Bean Shell, which is like a JavaScripting environment. And there's actually also support for JavaScript, which is kind of fun. Like scripting your spreadsheets in JavaScript is kind of neat too. And I think that might actually be Rhino, which is a JVM implementation of JavaScript. I'm not sure which implementation of JavaScript it is, but let's go over it real quick. Here's my presentation. Here's my presentation. Okay. So, and unfortunately the screen is really wavy, but so basically you can have your own, you can just put the scripts in your home directory. I'm kind of shady, so I actually put them in the share area where the installs are, and so it's in like user lib, OpenOffice, share, scripts, Python, probably some comparable place in Windows. And there's not, so one of the biggest challenges, I mean, there's nothing really like technically challenging about this. I mean, a lot of it's just like grunt work and trying to figure out the OpenOffice APIs. But one good sort of source is, actually I want to maybe try to choose my resolution. So basically, as far as I can tell so far, like the best way to actually figure out how to do stuff is just like their wiki page for the basic guide. So obviously it all started off that they had like a VBA clone, which was useful for scripting too. And so the examples translate pretty straight. So you can sort of just look at their basic examples and just translate them into Python without a whole lot of work. So basically, and you can do all kinds. I mean, you can script the entire everything across the board in Python just fine. But basically, for the most common routines, you just get your current document, whether it's a spreadsheet or like a Word processor text file, and then do stuff to it. So actually, in OpenOffice. So it's got, a pretty standard Office sort of setup where you can go to, there's basically some menus for the macros. And so the cool thing is, if you go to organize macros here, you can see the directories for the macros and the different languages that it supports. At the current moment, they only have like a visual editor for their actual VBA clone. So for like the rest of them, you just use a text editor or whatever IDE is. But so you can just go and open one of the macro windows. Come on, buddy. And so what these are is these are all going to be Python modules. And then the way it works is it just looks through them for functions on them, and then you can call a function on it. So here's like an interesting example, which will create a table inside the table or inside the document you have. And so this will be a function, and as you run it, and it creates a table, does cool stuff with it. And so the actual code for that is.
Can't see that.
Sorry. I guess I have to restart. It is. Everything was really awesome until I upgraded. Like seriously, like I was really impressed because since it's like Apple hardware, I mean everything worked out of the box. My wireless, everything. Then I upgraded, and then everything just. And so this is really how actually hard. And realistically, you should be doing this in your home directory. But so just like a really simple example, the hello world. So this is this is pretty much the simplest hello world. And so when you see this in the macro dialog, basically says like hello world, and then the little drop down, and then hello world Python. And so it just looks for the functions in here. And you can write classes and do anything else you want to, but it basically will just look for functions to invoke. And so it's doing simple stuff is pretty straightforward. You just use this sort of variable they have, labels on an axis to like a range of cells or something. So I'm going to try to actually use the dialog support to do that. And I'll just show one more quick example of just doing like a really simple spreadsheet manipulation in a spreadsheet. So here's a spreadsheet. So this is a super simple example. You get your document, you get the sheets for your spreadsheet, and then here's the first sheet, and you get a cell, and you can say super ChiPy cell or something. Save it. And then again, it shows up in that dialog, which you can put on the toolbar to set up like a key binding for it. And so here's the actual calc test file, and then here's the function, and then you can run that, and it sets this up. So as for just doing, just getting started, it's actually not too bad, and then it kind of sprawls out. But it's pretty great because I'm sure for like a lot of web applications, like I use some of the Apache projects for making spreadsheets, and every language has like your standard make spreadsheets in Excel. But if you actually need to do like really complex stuff, you need like the actual full functionality of like a bloated Office program, then it's pretty good. And you can actually do pretty interesting stuff if you need to do server-side processing too. because you can actually, I mean, you can connect to OpenOffice via like a socket and script it remotely and stuff. So if you don't even want to do GUI stuff, you just want to do like bulk processing, you can do that too. So that's just a quick little update on where the functionality is at. They're slowly working on improving it. You know, it's open source, so it's slow going. But it's pretty exciting because you can script the entire, you know, everything in Python. So it's pretty awesome. Yeah.
So a couple of questions. One is just kind of related to my experiences. The only other kind of similar experience I have would be Python scripting Blender, which is another application where you can do Python scripting. But with that, they have their own Python interpreter built into the thing, and they have and you can't import any modules to work with it. Like you can't import Blender renderer and then start pushing things into it. Is it possible at all to like import any of the modules and start to do any OpenOffice related stuff without actually spawning a process of OpenOffice?
Oh, I don't think so. No. No, because it's gonna like you if you're running something in straight. Maybe if you're using like C++ or Java, I think you might be able to do that. But I think once you get to like the Python bindings, I think you really have to have the like object broker started up and stuff. They've been making like pretty serious performance. I mean, obviously you still don't want to start it up, but it's actually been every release gets much better. They are like making it faster and fixing it.
This is the Python built into OpenOffice, and you have to launch OpenOffice to run it, right?
Yeah, it's just some version of CPython that they threw in a directory and put a couple of special configurations for it. It's kind of like with the Python support they're working on in Mozilla, where like once again they're throwing their entire own version of Python in a directory. So it's not awesome, but maybe, I mean it's awesome and it's not awesome. I find it pretty exciting because it's open source and you can do all kinds of really cool stuff. But it's a big clunky bloated stuff.
So it's just like if you put like another script in that same directory with the other macros written in Python, can you import that or no?
I'm pretty sure you can.
You're not.
I'm pretty sure you can.
Oh.
If you want to write just like a class or functions and other ones, yeah.
Okay. And basically, because it's a whole suite of Office applications, they're all scriptable like that, right?
Yeah.
Okay.
Yeah. Oh, let me pull up that. I didn't know if we had internet access, so I scrapbooked some of the wiki pages. This one? Oh yeah. Okay. Well, what's Scrapbook? Scrapbook is this like really cool Firefox plugin where it'll like capture entire pages for you, so you can view them, and it like saves all the JPEGs and stuff. And so this is like everything in a scrapbook for like train rides and stuff. If you're like hip to reading stuff on an L or whatnot.
Does it follow links at all, or just that?
No, it just there might be some.
Yeah, I think it. Yeah, it does, but you can't. You have to say capture page as instead of just capture page, and then you specify which links you want it to follow and what depth.
Yes.
But it takes a long time to download stuff.
So here's just like I don't know if it's still not even big enough, but here's just on the wiki. Here's the ones they actually have introductions for. So you can script like the text editor or word processor, the spreadsheets, the drawings/presentations, like the charts, the database, which is sort of like an access phone, the dialogues and the forms. Yeah, pretty much everything that's exposed via their comm system is scriptable, and that's pretty much everything because it's pretty cool.
Do we know what major revision of Python it is? Is it 2.4, 2.5, 2.3, 1.6?
I think it's 2.3 or up. I honestly don't know.
It's the stuff version.
Yeah. Okay. So okay. Yeah. We'll do that. just it's just sys version.
Yeah.
Is it a function of the property? Okay. So, it's 251. So, this is pretty good.
How do you control when the scripts get run? They can like load.
Yeah, well, as far as that, like, so far I've just used their macro dialog, and so I think it's pretty much the same as in like MS Office, where you can like, you know, you can put, you put a button up here, you can like, you put a control key or something on it. I haven't run them from anywhere besides like the macro editor yet. Yeah.
How was the Python macro for the other text editors? Or Office, like Word?
Oh, I mean, I don't think they exist. Well, maybe in this new .NET world, maybe you can use Iron Python. Like the last time I actually used MS Office was like 2 years ago, before I switched jobs and didn't have to actually like do any Office documents anymore. It was just like VB, Visual Basic.
You can definitely get Python though, because you have access to the common objects.
Oh, is it like actually shipped? I mean, could I just like fire
It's not
Office?
shipped, but I mean, if you install Python in the Web 32 extension, I think you can write.
Yeah.
Oh yeah, I just had to work with an Excel spreadsheet, and I found this really poorly documented library called XLRD that I'd never heard of before, but it can read and write native Excel files really easily, just for the gentleman around the corner if you're trying to read a Microsoft Excel. It's pretty good.
Are you sure it does both read and write?
I know for sure it does read, and it says it can do write, but I haven't.
There is one that does write. I don't know what it's called.
Yeah, I've used that.
Yeah, that's the one that writes.
It's
It does do it.
It works.
To know a subset of things if you're writing. You don't know everything if you're reading.
So I guess the answer to your question is if you use like some MS, what is it? I think it's Complex or something. If you use some hacker, you can probably script it. You can probably script MS Office in Python.
What exactly was the question?
You want to know, like in other Office suites, like maybe like WordPerfect or like MS Office, what the level of support is for Python. And I mean, without hackery, I think it's non-existent.
I mean, yeah, basically if they have a COM interface to it, then it's really easy because you essentially get Win32 all, and that gives you very transparent access to any COM object that essentially has published itself in this registry. So that, like for instance, iTunes, interacting with iTunes on Windows and actually on Mac is really easy because on Windows it publishes a COM server that you can just totally query it and get the current playlist and all of that stuff. And so I don't know for sure, but I wouldn't be surprised if Microsoft makes publishes a COM interface. Yeah. So it would actually be really
you can't just like
easy.
run it alongside your VB macros, can you? Like you can,
Yeah, you'd have to run it from outside.
So I mean, the kind of cool thing about this is it's actually part of the thing. It's like, run your, Python is like, except that, well, they don't have like an editor yet, but it's like, Python is like first class citizen here. We love our VBA clone, but it's Python too, in the same directory and as part of the GUI.
Yeah, I've actually done COM, like scripting of COM, like through COM and scripting Office applications. It actually works differently. Like you use your CPython installation that is installed on your hard disk. It's not, obviously Microsoft doesn't ship with Python. And it's not like hackery or anything. You just use the published COM interface as is.
And I guess I said when I say hackery, I mean basically like you have to like do extra stuff. Like this is this is very much part of like the product that they're like having you install, and it says so. Like it's in the doc, it's in the help files. It's like script us with Python right now.
So is there a way in the spreadsheet to invoke the Python functions in a cell like you would a VB function?
Yeah, it's pretty much exactly the same.
Okay.
So if you have like the OpenOffice basic example, you can just kind of translate it straight into Python. It is pretty. It's just a little clunky to learn, but it's honestly pretty straightforward. I guess that's it. Pretty excited.
Screen, or can I?
Oh, you can actually unify the screens if you want. You can use that FN plus that key button to unify them if you want.
So really,
Jeez, a little lip. Atul.
because they don't care.
Oh, sorry. It's okay. No, you're alright. Just put your arms down.
Okay.
That's awesome. I know, right?
Okay, here we go. This is my 7-year-old sister. Her name is Alexa. She has just reached the age where I am able to try to make her into a gamer. So here we were at Thanksgiving playing Settlers of Catan. And better yet, here she is playing Super Mario Kart with my cousin on my old Super Nintendo that my mom brought down from the attic. So I said, "Hey Alexa, how would you like to make our own video game?" And she said, "What? Can we really do that?" And I said, "Yeah, of course. You go do the artwork, and I'll take Python and Piglet and monkey up a really simple side-scroller engine." And she said, "Okay." So let's see here. So she decided that the game was going to be about Princess Toadstool from Super Mario Brothers. And she did all these drawings on paper with a and we just scanned them in. And the bad guy was going to be this dragon here. It's pretty fearsome looking. And the second player was going to be this turkey, which is what you get when you ask a kid to come up with a video game character on Thanksgiving. So I was inspired by a presentation I saw at the previous ChiPy meeting about, oh wow, now this terminal is way too big. A presentation I saw at the previous ChiPy meeting about
the green
a
button.
module called Piglet, which was reputed to be even simpler than Pygame to get started with. So I said, okay, let's give this a try. And if everything works properly, no, it's going to lose its connection. Here we go. All right, so here's the princess jumping over here. I made a very simple kind of physics engine, so there's gravity and there's friction. And that thing running back and forth down there is the monster she made up, which is a half cat, half pumpkin monster. And if I, well, the physics is kind of the other thing is I made the physics engine work well enough that I can like pick up this ball and then throw it and it'll bounce around. And then the other player can control the turkey at the same time, and you can fly, but not so that's what that was all about. But the only point I really wanted to make of this is that it's really cool to make games with kids because first of all they learn that these video games that they play are not just some magical thing that just God creates in the toy store. They're something that people actually make by, ingenuity and work, and it's they can do something themselves, which is, it's not going to be polished or anything, but it's going to be based on the same basic ideas. And then the other thing is, you get them interested in programming, and this is about the same age where I got interested in programming. And then the nice thing about doing a side-scroller is the physics engine means you get a chance to teach them about stuff like gravity and friction, because I had these constants for gravity and friction at the top of the file, so we could just play around with changing those constants and see how it changed the game. And we put the friction way down, and it's like you're walking on ice because your character keeps sliding, and so they start to learn about some basic physics ideas. After I reached this point, I wanted to replace my glitchy physics engine with a real one, so I downloaded PyODE, which is a Python binding for the ODE physics library, and it says on the PyODE website that it has no external dependencies, which is a filthy lie. It has about 5 or 6 undocumented external dependencies, which I had to discover from cryptic error messages one by one and install. So I'm still in the process of getting that working. Once I do get it working, I'll put up a tutorial probably and post it to the list about how to use PyODE together with Pygame to make a game with good physics. And then I guess the last thing I wanted to say is that Mom showed me an essay that Alexa had written for her 2nd grade, wherein she saved Christmas by creating a video game for Santa to give to all the children. Because like there weren't any. She had some crazy backstory. So she was obviously pretty inspired by